Hello everyone, and once more, welcome back to another episode of the Kerbal Space Agency. In this episode, we'll be doing something very special, the Pioneer IV mission, the first mission that did a lunar flyover, but also the Freedom 7 of Alan Shepard. As you can see, I jumped straight into the launch of the Pioneer IV. One thing you might have already noticed is how large this rocket is relatively to anything else we have ever launched. The Juno 2 booster, contrary to the Juno 1 rocket, is much more powerful and much larger as well, and contrary to the Juno 1, is not based on the Redstone rocket series. This very mission was launched on the 3rd of March of 1959 from Cape Canaveral. It was the first successful Pioneer mission, as the rest of them failed to get into orbit around the Earth due to a staging failure or a mechanical failure in general. So as already said, this rocket didn't get into orbit around the Moon. Instead, it had a flyby and then went to a heliocentric orbit. Heliocentric means that after the flyby, it went into orbit around the Sun. By the time it was at the Moon, it already had escape velocity relative to the Earth, so it was a matter of time until it got out of the sphere of influence of the Earth. And as one might ask, this is 1959, why was the Apollo as late as 1969 if we already had a flyby by then? Well, the answer is quite simple actually. As you will see on final stage separation, the final stage is really tiny. It only weighs about 6.1 kilograms, while on the other hand the Apollo spacecraft weighed lots of tons. It was the only probe out of the total 7 launched that managed to get into a lunar flyby. The next one that actually managed this was Ranger 6 at 1963. As you can see here, I skipped the orbital and sensor burn. The reason is simple, I had to recharge the batteries, so I had around 6 or 7 orbits around the Earth to be able to recharge them, and that was really boring to see, so I chose to skip it. The spacecraft at this point is performing the insertion burn that will bring it to the lunar flyby they will perform, and then in the end into orbit around the Sun by raising the escape velocity by the gravity boost it will get. To put things into historical perspective, the Soviets launched Luna 1 just weeks before the Pioneer 4. Luna 1 was the first craft to perform a lunar flyby. I also find worth mentioning that this was actually a NASA mission, not a United States Air Force, not a Navy mission, a pure NASA mission. Something you can notice on the map is that there are a lot more orbits down there. The reason is simple. Unfortunately, my contract pack got a bit messed up, so I had to do these videos off the record, but they are done now so I can continue on these missions properly. After the small correction burns are performing, we finally have enough velocity to escape the Earth. This is of course thanks to the gravity boost of the Moon. At this point I will be turning off the batteries so we can save the power until we are at the morning side where the batteries will recharge by themselves again. A satellite plate is already set up to look towards mission control, so one thing we don't have to worry about is being out of target once we're out there on the morning side. So as you'll be seeing the maps a few times now, let me take the time to explain what the orbits you're seeing are. The 3 highly elliptical are all Vanguard probes. The one that almost reaches the Moon is the unsuccessful Pioneer 3, which just like in real life, failed to reach the Moon and fell back to Earth. In this case, the contract was not to fall back to Earth, but I should do a deorbit burn at some point. And all the smaller near-Earth orbits are all explorers. In total we have 5 explorers, although in real life there was a total of 80 explorers. Also, you might have noticed to turn off the smaller antenna. The reason is there's no other satellite nearby to receive the signal, so all we need right now is a satellite plate relaying the communications all the way back to mission control. And here we are, we're finally in the sphere of influence of the Moon. Unfortunately something went wrong with the escape velocity, so we have to reboost this at the periapse around the Moon. Here you can see me setting up this maneuver. What's really interesting is, as I noticed in another test, there is enough velocity in this craft to reach nearly the equivalent of Mars called Duna in KSP. But even if we could make it there would be no point, as there's no communication satellite to be able to relay the signal all the way back to mission control, so it would be a dead probe orbiting Duna. And as expected, in a few seconds we'll have communication to mission control once more, so we can send the maneuver node and also relay the signal and the signs we collected around the Moon. So while the only data we collect from this mission is temperature data, what type of data was actually collected in the actual Pioneer IV mission? It was only radiation data from Geiger-Miller tubes. And you might wonder, why are we actually using satellite plate instead of using a proper antenna? Well, in KSP for some reason signals are much weaker, and the only reason to fix it is to use Realism overhaul, but we are not using this mod, so we have to accept that the signal is going to be weaker than it is in real life. For comparison's sake, let's mention that the original mission went with 7,230 km per hour relative to the surface of the Moon at 6,000 km of periapse, but as you will see, the velocity here was really much smaller. The speed here when converted is 3031 km per hour, which is not small, but is relative to the scale of KSP, which is much smaller. And at this point we are finally performing the burn that will bring us into heliocentric orbit, and we will also be waiting until we have signal again to the base so we can transmit the near moon science. So I mentioned that it passes around 60,000 km above the surface of the moon, but the original intention of the mission was to pass at around 30,000 km. At this point there was a photoelectric sensor that was supposed to trigger at this distance, but because of the higher distance it never triggered, so they couldn't transmit all the signs they needed. Going back to the original antenna, how did it transmit the data, you may ask, since it looked like a cone? Well, it was really smartly designed with alloy, so the cone acted itself as an antenna. So with the satellite plate being connected, it's finally time to transmit the data from nearby the moon and complete the contracted Astronaut near-moon flyby. Unfortunately, I forgot to transmit the telemetry data, but it was just the first craft to go there, it's definitely not the last. So I will do this in the next mission, it doesn't matter this much. And here we are approaching the final stage separation that will just bring the craft that will go into heliocentric orbit. So until then, let's do a very quick 10 seconds time acceleration until we're in the orbit around the Sun. I would really like to transmit data from this far, but unfortunately on KSP the signal isn't enough to reach the base. So, it's time finally to upgrade the vehicle assembly building. Why? Because, well, I need the action groups for the abort action. Manned missions need aborts, or the capability to abort just in case. So, this is a Freedom 7 flight of Alan Shepard. Even in real life, it was just a 15-minute mission, but it brought the first American into space. Freedom 7 was a Mercury Redstone 3, signaling the third use of the Mercury Redstone rocket. So the 7 in Freedom 7 definitely doesn't mean the 7th mission, it just refers to the 7 original astronauts of NASA. This way, they intended to pass a teamwork spirit with the rest of the 7 astronauts, the Mercury 7 astronauts, or the original 7 as they were called back in the day. Alan Shepard was really to be the first man into space, if it wasn't just 3 weeks ago that Yuri Gagarin became the first man into space. That was only because the Americans insisted to use a chimpanzee named Ham in the previous years of the Mercury rocket. So this is the mission that marked the beginning of the space race on both sides. The Americans knew at this point that they lost the race for the first man into space and the first man into orbit, and as well the first craft into orbit, so they had to take something that would take enough time that they could become first. And that, ever since then, knew it had to be the moon. This mission was launched on May 5th, 1961 from Cape Canaveral in Florida, and it was quite an eventful mission, to be honest. There were technical difficulties, and there was in fact a 10-hour delay in the launch of the mission. This is where the famous quote of Alan Shepard comes from: "Why don't you solve your little problem, light this candle up?" After 10 hours that he even had to go to urinate, because he didn't think it would take 10 hours to launch this. So Alan Shepard was also the first man to experience the high G-force experienced during re-entry. So let him allow how re-entry was himself.
G build up. B.
We are still in voice communication with the pilot.
9.
9G coming down.
Okay. Okay. Okay.
So I suggest it was really an intense experience for the pilot, but the mission was a complete success, and with that, it's time to say goodbye and light these candles up.